Okay, we're going to start 8.2, properties of chords in a circle. So let's just review what a chord is. A chord is a line segment that joins 2 points on a circle. Okay, so from here to here would be a chord. The longest, which was the trivia question for your parents, the longest chord in a circle is the diameter. That's the longest chord that you can have. Now, I've got radius written here, but radius is not a chord because it doesn't join 2 points on the circle. It comes from the center of the circle to the outside edge. Okay, so chords can have special properties. Okay, so in this one here, we're going to go over a few vocabulary words as we go through this example. In any circle with the center O and chord AB, okay, if OC bisects, okay, and that's got a special word, that's got a special meaning in math. Bisects means it cuts it exactly in half. And we know that it bisected AB because these lines tell us that this piece, CB, is exactly the same size as AC. And when that happens, now here's the other vocabulary word you need to know and symbol, then OC is perpendicular. So this symbol here stands for the word perpendicular. And perpendicular is an important word in math. It means that it meets at 90-degree angles, okay? So if OC is perpendicular, so OC right here is perpendicular to AB, then AC, this piece here, is exactly the same size as CB. The perpendicular bisector of A goes through the center O, okay? That's important. Okay, so let's go through now. We're going to take this information, this property of a chord in a circle, and we're going to do some work with this circle. So it says find the measure of the angles in a triangle. So we're looking for angle X, angle Y, and angle Z. So right here we can see that AC and CB are exactly the same size. And in fact, what we've created here is what we would call an isosceles triangle. And special things happen in isosceles triangles. Okay, you can see that this is a radius, and this is also a radius, which means this side and this side are exactly the same as well. That means that this angle and this angle are exactly the same. So if you don't remember that from grade 6, okay, you should have taken a look a little bit at isosceles triangles. That's what happens. Okay, so what we can do here is we know that angle X is a 90-degree angle. So I would write that down right away because that's my given, right? I already know that. And then I know that this angle here is 30 degrees. So then I can tell you that angle Z is also 30 degrees because we've got an isosceles triangle, and this angle have to be exactly the same. Now they've asked us to find Y as well. Well, we know this is 90 and this is 30, so that added up to 120, and we can simply take that away from 180 and we can get 60 degrees. Okay, and there's a solution typed down here, but I just wanted to talk through it, okay? So just a reminder that in an isosceles triangle, the two base angles, these ones down here at the bottom, are equal, exactly the same. Okay, so let's just take a look here. We're going to find the value of angles X and angle Y. Okay, so immediately we can see that OC bisected AB, which makes these two exactly the same. That means that they met at a perpendicular angle, okay? So OC is perpendicular to AB, so angle X has to be a 90-degree angle. So we know that. Okay, check mark there. Now it says what's Y? Well, we know that we can go 90 plus 40, which is 130, and we can subtract that from 180, and we can get 50 degrees. So we're done that one. Okay, now these ones here, I don't like to look at them sideways like this, so if you're like me, okay, I flip it like this a little bit. You can see that OC is perpendicular to AB because these two pieces are congruent, and that means that it bisected it, and therefore angle X has to be a 90-degree angle. So we're going to write that one down right away because that's easy. Okay, so OC is perpendicular to AB. Since OA is a radius, okay, and this is also a radius, so this one's 55 degrees. That means that angle Z also has to be 90 degrees, okay? The triangle is isosceles. Okay, so we figured that out by using chord properties and by using the angle sum property. Okay, so there's two things that are going to keep raising their heads in this unit, and that is the angle sum property and also the Pythagorean theorem. So we just went through angle sum, so obviously we're going to use Pythagorean theorem now. Okay, O is the center of the circle. Find the length of chord AB. Now, this doesn't have the congruency signs here, symbols, but it met at a 90-degree angle, so we know that this is perpendicular, so we know that it bisected. That's the only way that can happen. Okay, so if I wanted to find AB, I can solve for this piece right here. I can multiply it by 2 because these two are exactly the same. So it's going to look like this. This is C, this is A, this is B. So I'm going to use the Pythagorean theorem, obviously. I mean, it says it up here in the title. So I've got 10 squared is equal to 6 squared plus B squared. So 100 is equal to 36 plus B squared. Subtract 36. 64 is equal to B squared. My last step is the inverse. So B is equal to 8. So I know that from CB is 8. So if I wanted to find AB all the way, this side is exactly the same. I would multiply it by 2 and I would get 16 centimeters. So that's how I do that. Okay, so find the values of A and B. So we're going to separate them now. Okay, we know they're exactly the same though because this met at a 90-degree angle. That means that OG bisects EF. Okay, these two lines are perpendicular. We've created a 90-degree angle. Therefore, we have a right angle triangle we can work with. C squared is equal to A squared plus B squared. So I have 13 squared is equal to 5 squared plus B squared. 13 squared is 169. 25. And subtract 25 from both sides and get 144. And then we find the square root of that, and B is equal to 12. Okay, so B is equal to 12, and therefore, or I'm sorry, yeah, so that means section A is 12, and B is also 12, because they are exactly the same. Okay, so there's a couple practice questions I just want you to try, and tomorrow we'll take these up, and we'll do another assignment because we're going to take our time through this.